Hi everyone, this is the first lecture video for week 9. We're getting into really the biggest topic over the whole course, which is high-level programming. We're going to get into programming with Python, but for this first lecture, we're just going to talk about high-level programming and high-level programming languages in general. So let's jump over to the slides. This is basically the intro I just gave, so let's go on to the next slide. So object-oriented programming versus procedural programming. Procedural programming is programming focused on breaking the needed tasks down into smaller tasks that can be reused when possible. So maybe if you need to calculate the average of a set of values, you would write a chunk of code that does that, and then you can call that one chunk of code over and over again whenever needed. Object-oriented programming is programming that focuses on organizing data into objects that contain related data and functions. So if we have a program working with students, we might have student objects that would store, name, ID, grades, courses, things like that. And then we might have another type of object, for instructor, for course, for all these different types of things. These two types of programming are not mutually exclusive, but there's time where you're programming focused more in a procedural way, where you're focused more just on kind of breaking the code down itself, and there's times where you focus on the more object-oriented version, where you're really focused on breaking down the data and code into appropriate objects. So let's talk about object-oriented for a little bit. Object-oriented design focuses on how to break a problem down into objects. So what's an object? An object is an entity that holds data and functionality related to what it is. And this often represents a real-world object. So we might have employee objects, student objects, course objects. It can also be more abstract than that, but for our examples, we'll stick to kind of the clear idea of representing a real-world object. So in object-oriented design, problems are solved by isolating the objects in a problem. Figure out what we're going to have as an object. Are we going to have students as objects? Are we going to have courses as objects? Or maybe students will be an object and courses won't be. There's often a lot of flexibility in how you can do that. There might be a better way, but there's often many ways you can take the same problem and break it down into different types of objects. Once you have the different types of objects you want to determine the properties, the data, and actions, the functionality, responsibilities that each object will have. What does a student need to store? What does a student object need to be able to do? And then you want to let the objects collaborate to solve a problem. So a student object would hopefully be able to register for a course, and maybe in that way it would interact with a course object. So let's kind of use an analogy here. Let's say you and your friend are fixing dinner. What objects are involved in this? There's you, there's your friend, there's dinner. You might even have other things like the kitchen, ingredients. There's a lot of things that could be used as objects. So what classes would you need? So for a class, you might have you and your friend are both people. So we might have a person class or a people class. People might have a name, eye color, birthday as their data. What can they do? Well, in this case, people can shop, buy ingredients, cook, mix, basically do all the steps necessary to fix dinner. An instance of a class. And this is kind of the distinction between a class and an object. So an instance of a class, you and your friend would be instances of the class people. You each have your own name and eye color. You each can shop and cook. And then those objects could collaborate to fix dinner. I think the next slide has more on this. Here we go. So let's talk about class versus object. An instance is an object. So the class. So let's talk about the person class, the people class. The class is a blueprint of that type of object. So the person class is a blueprint saying that a person has a name, a person has an eye color, a person can shop, a person can cook. Objects, or instances, are specific people. They're objects that have been created following the blueprint of the class. And so if I have an object for Chris, it would have Chris, it would have eye color brown, and things like that. Another person, might have the name Steph, eye color blue, and different information. And so the class is the blueprint, and from that blueprint, you can make as many objects as you need to represent all of the people in the class, all the people in the for the program. So classes contain fields that represent the properties, name, eye color, and behaviors, responsibilities, shop, cook of the class. One thing, and I'll try to be relatively consistent, is there's a lot of synonyms for the same thing. So classes contain fields. Fields, properties, data, data members, there's others that I'm not thinking of right now, are all words for the same thing, meaning just the information that the class is storing. For example, name and eye color. Behaviors, responsibilities, methods, functions, these are all basically the same thing. What can an object of the class do? So a method is one of the ways to talk about these behaviors. A named algorithm that defines behavior, like shop and cook. So this is just like, what can the class do? The method is an action, whereas the properties are information. So here, if you were thinking about things that you needed to store, and you needed to store this information in a program, you needed to have a birth date, a marriage date, dog's birth date, you might realize, oh, these are all dates. So we might create a date class to represent a specific date. The class is the blueprint, but when we needed to make an object to store the birth date, we'd create an instance of the date class. We'd create an instance to represent the marriage date. We'd create an instance to represent the dog's birthday. So this is the blueprint. These are the actual objects constructed from that blueprint. And so here again, the class date is the kind of the description, the blueprint, and the objects, instances of that date class. So what actions would date have in the real world? And so we call an object's interactions with other objects its responsibilities. Things that this includes is being able to create itself. We need to be a way to create dates. Know the state of the fields. Know what information is in the class. Compare itself to another date. Is this one before or after or equal to? Return a date a number of days before, after. These are things that a date class might do. If you have two date objects, you might want to know how far apart they are. You might want to know which one comes first, things like that. And so for the date class, you'd have things like get month, get day, get year. And those are just ways to check what the month, day, and year are. The month, day, and year are the data. They're the properties. But get month, get day, and get year are actually the behaviors so that you can check the month, day, and year. Classes may store information that you can't actually check. I'll talk a little bit more about that in a bit. So the responsibilities. Knowledge responsibilities, like the one we just talked about, just return information about the object's variables, about its properties. Action responsibilities are a little more complicated, but they're also a little bit more intuitive. Like if you have a student class, enroll in course would be a responsibility, transfer might be a responsibility, things like that. So principles of object-oriented design. Encapsulation. This is the bundling of data and actions in such a way that an object controls its own data and behavior. And this is the reason why objects will have the information, but then they'll also have getters to allow that information to be retrieved. Because when you're creating objects, you usually want to create them that they control themselves. A date controls its own day, month, and year. And outside code could only change that kind of with the date's permission and knowledge. And so what objects often do is they will say that they will store their information in a way that it can't be reached directly from the outside. They make that information private. And so that outside code can't directly say what is the date. The outside code has to use a behavior and say, get the year for me, get the month for me, get the day for me. And so those are publicly accessible ways to access the knowledge. And this way the date can make sure that all of the values it contains make sense. For example, let's say that an object let outside code just come in and change the day, month, and year any way they wanted. Outside code might come in and say that the date is February 30th, 2020. That's obviously nonsense. And encapsulation is one way that the object can protect its own data, make sure that the data is always valid by not just letting other code come in and change the data without being checked. So encapsulation, an object controls itself. Inheritance. Inheritance is a way in which an already tested class can be used to make a new class from it that inherits the properties the application needs and adds to them. One example of this might be if we have a student class. We might then create an undergraduate student class and a separate graduate student class, both of which extend the student class. And when they extend it, the undergraduate student would inherit student ID, name, everything that's already there, and then can add onto it, say that the undergrad student also needs these other pieces of information and behaviors. And so this is a way that you can take one class and build on it to have a class that has more information, more behaviors, but is still essentially the same in a lot of ways as the original student class. Finally, polymorphism is the ability of an object to be treated as different types, and this is based on inheritance. If a truck class inherits from a vehicle class, so a truck class extends vehicle, a truck instance can be used as a truck or as a vehicle. In the example that I was just talking about, if you have a student class and the undergrad class extends it, then an undergrad object can be treated as an undergrad, but it can also be treated as a simple student. And so this is the idea that one object can be treated as having multiple types. One of the courses that I've been teaching here, and I expect to continue to teach for a while at Langara, is 1181, which is basically an entire course on object-oriented design and object-oriented programming. And we talk a lot about these there. And so maybe I'll see some of you in that course in the future and can explore more of how to use these in actual code. Because right now we're talking about object-oriented programming, but we're actually not going to do a lot of object-oriented programming. We're going to focus on procedural. So, running high-level programs. A program written in a high-level language must be translated into machine code. Remember we had machine code and assembly code? Well, in the end, even though we're programming in a different language, it still needs to be converted down into machine code that can be run on the processor. And the machine code is what is executed. Compilers and interpreters are two different types of tools that allow us to run our high-level language on a processor. So a high-level language is a language that provides much more powerful and usually more English-like instructions to use. And so this will be clear when we start writing code. For example, you might have a method, a function that's just called square root, and it lets you take the square root of a number. So instead of having to do all sorts of very small, minor, steps to do that, you can just use this one line of code saying take the square root of 100, and it sounds a little bit more like English, and it's a much more powerful line of code. And that's what we'll get with high-level programming. A compiler is a program that translates a high-level language program into machine code. So it'll take the high-level language code and translate it into machine code that can be run on the processor. And it does this for the entire program at once. So it'll normally take one code file that's written in high-level code and convert it into a code file that has the machine code. Languages such as C and C++ have to be compiled, and they have to be compiled for a specific OS. So if you compile the code for a Windows machine, it won't run on a Mac. If you compile the code for a Mac, you can't run it on a Windows machine. And so even though you have the same original code, it has to be compiled separately for different types of computers. And so once you've compiled it for Windows, you can pass it on to be executed on a Windows computer. Once you've compiled it for Unix, you have to pass it on. You can pass it on to be run on a Unix computer, and so on. And so this is one of the disadvantages of a language like C or C++. An interpreter is a translating program that translates and executes the statements of high-level code in sequence, one at a time. And so an interpreter can just take a program and run it one line at a time, converting each line to the needed machine code, instead of translating the whole thing at once. And so the compiler we were just talking about does this for the entire program at once, whereas an interpreter does it one line at a time. You can view an interpreter as a kind of simulator for simulating the program. For some languages, you can either compile the whole thing or use an interpreter, and some languages are run always compiled or always interpreted. So let's talk about Java, because Java was introduced in '96 and became very quickly popular. I started my undergraduate in 1998. And when I took my first full programming course, it was being taught in Java. So 2 years after being introduced, Java was being taught, at major universities. And so it was very popular very quickly. And one of the main goals of Java was to make Java very portable, make it easy for a program to be run on different types of computer. And so Java takes a different approach than C or C++ did. Is instead of compiling Java straight into machine code, Java is compiled into a standard machine language called bytecode. And so this bytecode can't be run directly on any processor, like machine code can. What you do with bytecode is that's given to a software interpreter called the Java Virtual Machine, the JVM, that takes the bytecode and will execute it on the computer. And so you compile Java once into bytecode, and what there is there's a different version of the Java Virtual Machine that runs on Windows, there's a version that runs on Unix, there's a version that runs on Mac. And so then you can give the same compiled bytecode to any computer, and as long as that computer has a Java virtual machine installed, then it will be able to execute the program. The Java virtual machine takes the bytecode and allows it to be run on any type of processor. So let's talk about some more programming languages and some different types. The first type, and by far the most common, is the imperative paradigm. Programs describe the processing. The programs basically say, do this, do that. And Java, C++, Python, Visual Basic, most of the programming languages you can probably name are imperative, if not all of them. So procedural and object-oriented programming is both in the imperative paradigm. But there's a whole nother category of languages following the declarative paradigm. And so the program actually doesn't describe what to do, it describes the results that you want. Lisp, Prolog, Scheme, a lot of these languages I've seen used in artificial intelligence. They have other applications as well, but instead of giving the steps for something to be done, you basically describe kind of the end point. You describe steps. We're just going to talk about this a little bit, and then, when we're learning high-level programming, what we're learning is imperative. But it's interesting to see the range, a little bit of the range in programming languages, because there's a lot of programming languages that look very different than these imperative programming languages. And so we'll see a couple of them. So declarative programming. These are functional. There's two versions. There's declarative and logic. In the declarative functional, you have functions based on the mathematical concept of a function. Something like where x equals y plus 5. And so if you know y, then you know x. Lisp and Scheme are examples of these. And then there's logic-based declarative program, based on the principles of symbolic logic. So these will have statements that declare facts about objects and relationships. We're going to see an example that uses like a family tree for this. You define rules about them, and then you ask questions about objects. And probably the most common example of this is Prolog. So here's Scheme. This is one of the declarative ones, where we say you can multiply 3 and 4. Here's kind of combining some more steps. Here's checking the length, and here's checking the max of these numbers. This is really more difficult to describe and explain, so I'm just going to kind of carry on to Prolog, where Prolog's a lot easier to make some sense of. And so we see some different lines here. The first 4 lines are declaring direct information. They're saying that Trudy is the mother of Sally. Saying that Tom is the father of Sally. Tom is the father of Erica. Mike is the father of Tom. And then we declare some logical rules. We say that if Z is the parent of X and Z is the parent of Y, then X and Y are siblings. And then we have rules that say that the father of a child is the parent of that child, the mother of a child is a parent of that child, and so that's how we can take these rules, this data, match them up with these rules, and answer questions. And so here it's going to ask, is Sally a sibling of Erica? This is asking a question. And to find this answer, it will take these pieces of data, apply them to these rules, and it will find out if it can make this conclusion, yes or no. And that's the idea of this type of logical programming language. now let's get into the imperative languages, what we're going to be working with. So we're going to discuss important ideas associated with procedural and object-oriented languages in the rest of this chapter, focusing on procedural. For some, we're going to look at the functionality provided in the languages, and then we're going to move on to actually programming in Python. So we're not doing any programming in this lecture. We're going to kind of look at some different languages and see how they're similar in a lot of ways. Because for the most part, if you learn to program in one of these languages, it's very easy to move over to programming in another, and you'll kind of see why. So the first idea, and this is an idea we've talked about multiple times, is data type. There's different types of data a program can store. You know, we can store numbers, we can store text, we've talked about Booleans. And so a data type is a description of the set of values and the basic set of operations that can be applied to values of this type. So numbers have some processes you can do with them, multiplication, division. Text has different things you can do with it. Booleans, you can use and or. And so depending on the data type, you can use a piece of data in different ways. Strong typing. Some languages use strong typing, some don't. If a language is strongly typed, this requires that only a value of the proper type can be stored into a variable. So in C++ and Java, when you make a variable, you say that this variable is going to store an integer, and then only integers can be put into that variable. Or you say that this variable can store a string, and then only strings can be stored in that variable. Other languages, like Python, that we're going to use, and JavaScript, are weakly typed. They don't have this requirement. When you have a variable, you can store any type of data that you want in that variable. There is no fixed requirement. So data types, numbers, sometimes they'll be combined into a single type number. Other languages will split them into integers versus real numbers, floating point numbers. Some languages will have even more splits than that. Text, a lot of languages just have strings, as we've talked about before. Some languages will have a separate data type for a single character of text. And finally, Booleans, true and false, and the different operations you can do with those that we've used in the past. So, declarations. A lot of languages use declarations. A declaration is a statement that associates an identifier, just a name, with a variable, an action, or some other entity within the language that can be given a name. The programmer can refer to that item by name. And so basically, like if we want to create a variable x, x is the identifier for that variable. If we want to create a method called square root is the identifier for that method, for that function. A reserved word is a word in a program language that has a special meaning. Like these will be things like function, which will be used to create a function. True and false have a specific use for Boolean values, so those will be reserved words. So those would be specific words that you can only use for their specific purpose. Otherwise, you'll cause problems. Case sensitive. In almost all programming languages, uppercase and lowercase letters are considered different. This should say uppercase and lowercase letters are not considered the same. I'll update the slide before I post it. That's what case sensitive means. So if you write a lowercase x and then you write an uppercase x, those are two different names for a variable. And so you have to be very careful about this. This is one of the places where a lot of beginning programmers have a lot of trouble remembering that you have to match uppercase and lowercase perfectly, or else your program may not run. So here are declarations in a couple languages. Python doesn't use them for variables, but here we have an example for Visual Basic. It uses the dim keyword, reserved word, to create a variable. C++ and Java, we have the type float, sum equals 0.0, so this is creating a variable called sum that must store floating point values. These are integers being created, and then once you've done this, you can assign them values below. An assignment statement, we've actually used these before in our pseudocode. An assignment statement is an action statement that says to evaluate the expression on the right-hand side of the symbol, which is usually the equal sign, and store that value into the place named on the left-hand side. So usually the left-hand side will be a variable, just say x, and then you'll say x equals, y plus 10 times 20. And so that whole expression on the right side will be evaluated, and whatever value is created will then be stored, assigned to the variable on the left. Along with variables, you can create constants, and that's just going to be basically, it's like a variable, it has a name, it has a value, but you're not allowed to change it. Once you create it, it will always have the same value. Here we have examples of input and output. C++ uses things like cin and cout. Java uses a scanner to take input. System.out.println displays stuff to the screen. Python uses an input function and a print function. We're going to see those and use those a lot. And Visual Basic displays things in a graphical program, so it has kind of different techniques for displaying things. Control structures. We've talked about these before. Control structures are instructions that determine the order in which other instructions in a program are executed. Can you think of ones that we've used in the past when we're using pseudocode? Well, the first one is selection statements, if-else statements. And if-else generally look very similar across all languages, and you can see all these examples where you see an if, you see a condition. If the temperature is greater than 75, do this, else do this. Here's Visual Basic, C++, and Java, and they all look almost the same. This is why it's generally easy to, once you've learned programming in one language, to move over and work in another language. And then the other control structure is repetition, the while loop, where we say while, then we have a condition, and while this condition remains true, you repeat the code inside of that while loop. So we have 3 while loops here: Python, Visual Basic, C++, and Java. So again, you can see how similar this all is. Functions, also called subprograms or methods, are chunks of code that have been named and can be used when needed. So if there is something that you need to do over and over and over again, instead of rewriting that code 10 times, you can create a function, and when you need to use that code, you can just call that function. And so that's a way to reuse a piece of code without having to repeat the code over and over. I think that's it. So in the next lecture, we're going to start getting into Python, creating simple Python programs and running them. You will be able to run Python on your computer, but I am going to focus on running it through a web browser. So we'll talk more about that when we get to it. Let me know if you have any questions, and I will see you in the next video. Bye.